All right, in this mini lecture, we're looking at this polynomial function with hopes of solving it. So we're looking at y to the third plus 6y to the second minus 31y minus 36. So in looking at this, it's a cubic function. Throughout our time in algebra, if you're looking at this video, you're likely taking algebra or have taken algebra. We haven't learned how to solve anything other than a linear function or a quadratic function. So to solve this cubic function or anything higher, we'll need to use what's called the Rational Zeros Theorem. So let's go ahead and solve that. So with the Rational Zeros Theorem, we're told to identify our P and our Q, right? We're going to make this ratio P over Q. Our P is always our constant term, and the Q is always the leading coefficient. So again, the P will be your constant, and the Q is your leading coefficient. So next, we want to look at our P and Q, our P being 36, and our Q being 1. And now write down all of the factors of 36, and then all of the factors of 1. So 1 is a factor, 2, 3, 4, 6, 9, 12, 18, and 36. These are all factors of 36. For the number 1, the only factor is 1. All right, now we're to create that ratio P over Q according to the Rational Zeros Theorem. And in creating that ratio, we're going to use the positive and negative excuse me, roots of each one of these. So we're going to say positive negative 1 over 1. And then we can say positive negative 2 over 1, right? And I'll go to the next one. Positive negative 3 over 1. Positive negative 4 over 1. Positive negative 6 over 1. Plus minus 9 over 1. Plus minus 12 over 1. Plus minus 18 over 1. And plus minus 36 over 1. So I've exhausted all of my factors for P over Q. So now I'll go ahead and simplify each of these. So 1 over 1 is just like saying 1, right? 2 over 1 is like us saying 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is just 6. 9 over 1 is just 9. 12 over 1 is just 12. 18 over 1 is 18. And 36 over 1 is 36. So now we see that we now have all of the possible rational zeros. All right, so that narrows it down to at least, how many do we have here? 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 possibilities to be the actual zeros, right? So that's pretty good because first we had nothing. We didn't know what the answers could be, what the zeros could be. So now we have 18 possible rational zeros. All right, our next step is to go ahead and use like a trial and error method. Go ahead and take a guess at which one of these may be one of the zeros. So I'm going to try and say maybe one is y equals maybe negative 1. I like to always use a positive or negative 1 if it's there. Some of the times in doing problems like this, we may have fractions as possible rational zeros. And I think fractions are a little bit harder to do. So I go ahead and use the whole numbers. So in trying y equals -1, which is one of these possible rational zeros, I'm going to have to use synthetic division. So I'll place that -1 in the box, and now I'll write the coefficients of the original polynomial function. What are those coefficients? They were 1, 6, -31, and -36. All right, so I'll write just those. +1, +6, -31, and -36. And now I'll complete the synthetic division. If you need practice on synthetic division, just feel free to go back to one of the earlier videos in the playlist. So we drop down the 1 times that -1 in the box, we get a -1. 6 minus 1 is 5. Times the -1 in the box, we get -5. -31 and -35 is -36. Times the -1 is +36. And look here, we have a zero remainder. What does that zero remainder tell us? That zero remainder tells us that x plus 1 is a factor, meaning -1 is a root. So this worked for us. If for some reason we did not get a zero remainder, then we would just cross out this y equals -1 and say, let's go try another one of these possible rational zeros. And we would just keep trying until we found one that goes evenly into our function, right? Because one that goes evenly into our function tells us that that linear factor is a factor of our function. So if we have y equals -1, then the linear factor would be y plus 1, right? Because y plus 1 equals 0, set it equals 0, you would solve that and you would get -1, which we just worked through and realized that it was one of the zeros. All right, so now in our synthetic division, we got a solution. Well, our solution can be written. And how can it be written? So we think back. We say to ourselves, what is the largest coefficient? I'm sorry, largest exponent in the original function? It was y to the third power. So we drop down 1 in our solution. So we make it 1y to the second power plus 5y minus 36. And that's equal to 0. All right, the next thing we need to do is go ahead and factor this quadratic right here, right? So if we have y plus 1, we're going to factor and say to ourselves, what times what makes -36? And the same two numbers have to add or subtract to make 5. I'm going to say 9 and 4. 9 times 4 is 36. And in adding, subtracting 9 and 4, we can somehow get this 5. We just have to get our signs right. I think a +9 and a -4 will get us a +5. And then multiplying a +9 times a -4, we would get -36. So that works out. So now we have 3 linear factors set equal to 0. We can go ahead and set each one equal to 0 separately. So y plus 1 equals 0, y plus 9 equals 0, and y minus 4 equals 0. So let's go ahead and solve those each. So we get y equals -1, y equals -9, and y equals 4. So we have now solved it, and we have found all of the roots. This -1 was already given to us when we found it out. Well, I don't want to say given, maybe. It was given as one of the possibilities, and we found that one to be true through the synthetic division. We did our synthetic division and got a quadratic. We factored it, and then we were able to set those factors equal to 0 and solve for at least the other two. So if this video helped you in any way, please be sure to hit that like button. Feel free to leave a comment and let me know what other topics you may be wanting to hear about or any questions that you may have, and I'll get back to you. Feel free to share to anyone who you may need to, and also go ahead and subscribe so you'll get all of the alerts of new videos. Take care.